TJ's is crazy food.
Yeah.
Then they hired me.
Yeah.
So I had up and down, and like I had pretty much 4 years with them, with J. Morgan, and then I worked for eBay and PayPal. Yeah. I've been hanging around and looking things about, and then I worked for 1 year recently, and that's one of the worst that we have. The technology was really good there. I like their business domain. The problems that they do small.
Yeah.
But I was so done with that. And again, when I moved here, I enjoyed the where did you work?
I went to Repetitive.
Oh, I see. It's in the downtown.
Spirit Settlements.
Nice. Sorry, what is it?
Most of it is in New York. We have a lot of
You lived in New York for about 8 years.
Okay.
Yeah, and so I was thinking of startup, which made us to move to Chicago because that's startup to have the financial economy here. So we moved 2 years back. I'm still living in Chicago.
Now, it seems like people either want it or hate it.
Well, the thing is, the least high. Wait, that's me too. Right?
Yeah. Thanks to the very similar to stuff I'm doing, but we're gonna sit at the deck. Excellent. Yes.
We will send it up. Oh, here we go now.
I keep asking you about the text.
No worries.
I'll be back for Mystery Center.
Yes, there's a cocktail. I think, is it here or is it somewhere else? I forget. Is it at 4 a.m.? Okay, so it's at the other one. All right.
And but it's still late, but it's still better for me because I'm family set up.
Yeah.
In my young age, in New York and then life, I still miss like this great. But this really works well for us, yeah. This situation is really good.
You guys have all such
Yeah, we live in the same.
Oh, gotcha.
Yeah. Small view.
Thank
This is the first time I came to the north side. But I think one of the Irish St. Patrick Day, I came to say we have for years.
Gotcha.
They're the Irish pubs.
There's,
Yeah. Once, that's it. Where I used to have 600 people at home. Me too. Well, unfortunately, I had to pay.
All right, yep, no, it was good to see you. We can replay. Keep in touch.
Yeah, where's TJ? He's in elsewhere. You said the
Trevor, yeah, so Trevor is probably at important. Just want to say hi to him. He's been at registration for most of the day.
Okay, so it's about like 2 blocks.
Not even. It's like
What's the number?
if you hit the streets on this side, walking up to the Emporium, you come too far.
Oh,
It's not even 1 block. It'll
Okay.
be on the right. You'll see video game like arcade.
okay.
So once you see that, you're getting look at it. It's
Okay.
important.
Thank you. Very nice to meet you.
Yeah, it's good to
Goodbye.
see you. Yeah, thank you. Thank you. All right, I don't know what's going on, so I do have a link. It's not showing up in the search, so it's like you can just manually type it out and just send it. Although the last time I did that, I get a porn site, so hopefully I don't fat finger it this time. I will test before I go. I think that's the trick.
half part of your taco yesterday.
Oh, good.
Where you were?
So I am an independent. So I have, yeah. So I do my own thing, but I work for kind of larger companies, mostly in Chicago. Right now, most of the companies are e-com companies, although I have done financial in the past. It's just my e-com friends are the ones doing all the things that I want to be doing. So that's how that works out at the moment. So yeah, no, it's been one of those things that I wanted to do 7 years ago, and my wife was willing to let me do it. 3 months pregnant, and
Go off and be an entrepreneur.
yeah, 3 months pregnant. She said I just had to figure out health insurance, and I figured out health insurance. So okay, good.
Delivery baby's expensive.
Yeah. So you know, I was able to figure that out. So I was able to do it, and it's been the rest is history.
Yeah.
So to speak, it's been a good model for me because I enjoy kind of doing multiple things. I can do bookkeeping, I can do the business side. I don't mind selling. You know, breaking out of a program, heads down programmer mode every once in a while.
So you do like a lot of kind of metrics, or you guys do like average modeling or tax rate stuff?
So I don't do, so what do you mean by that? So again, like right now, a lot of my work is in commerce. So I have, so time series stuff, not really ever come up in commerce operations except in monitors. So I do a little bit of work with some of the solutions that deal with like monitoring Prometheus. So, you know, some of the stuff that we were talking about in earlier talks, I have clients that are building that sort of thing out in their stacks. I just want to get this link up and then we can get moving. I don't know what I'm using now. Becoming my problem. But you're the caboose on this, so if we start 3 minutes late, we're okay. But I just don't want to make anybody late for any of the fun All right, so why don't we get you up there and set well? So let's make sure that you're feeding first of all. Do you have HDMI? Are you sharing? Yes, you're good? Yeah. All right. So I have, so the title of the talk changed now?
Slightly. I mean,
Okay.
I just wanted to encompass having everything.
No, it's fine. I just, wanted to make sure that I introduced the talk properly.
For sure.
So it's Markowitz with House. So I'll just see you talking about we're going to say All right. So for the last talk on the Apache Roadshow Chicago track, on the FinTech track, we have Joel, who's going to be talking about Apache Roots, or Mahout, or however you say it. Thank you.
Thank you. Markowitz with Apache Mahout. That's how I'm going to say it today. Go with it. My name is Josh Kleiner. I work for a company called Refinitiv. I am more of a Python programmer. This is my foray into Apache, Mahout, and all the windfalls that came with it. All right, so this is going to be my agenda for the talk today. First of all, who am I? Josh Klein again. Who is Refinitiv, the company that I work for? Who is Markowitz? Who is modern portfolio theory? And then we're going to go into why is this a problem in finance, why is this a problem in data science. Then we're going to go kind of step by step and show you the breakdown of the differences between the code between Python, between Mahout, and then like the mathematical implementation of it as well. And then some takeaways. All right, so who am I? My name is Josh Kleiner. First of all, I want to come clean. I am not a developer. I'm actually a salesperson. So why should you listen to me? That's a good question. One, I'm not going to sell you anything. Two, I got really good advice from a professor when I was taking my MBA. More or less, he said, learn to code. And he didn't say it on Twitter, and it wasn't 2018. So I thought it was pretty good advice, and I went about learning R. Now, for those that aren't very versed, R is a statistical programming language. It does a lot of great things. It doesn't do traditional programming very well. So in my role as kind of a data advocate for our developers, I kind of reached the natural end of how valuable R was. So I started my foray into Python. And then from there, because I had a wealth of data at my disposal, I ran my natural wits end with Python as well. Which, after doing a few things in AWS, doing a few things natively on a few different machines, trying to play with getting better processors, I realized, you know what, this is eventually going to be a problem. Why not find a better solution? Apache Mahout, however you would like to pronounce it, seemed like a natural end to that. So I decided to go down a rabbit hole and figuring out how to use it. So a little bit more. Raise of hands, anybody in the audience? Have you heard of Refinitiv before? No? Well, everybody at home who's keeping score, largest startup in the world. If you didn't know that, I'm not going to blame you. We had a little bit of head start. We used to be the Thomson Reuters financial risk division of the company. About 8 months ago, Blackstone private equity came through, decided to alleviate Thomson Reuters of that division, took us private, one of the largest M&A LBO deals in private equity history. And here we are today. So what is Refinitiv? I'm just going to go through a quick once over here. So we are a data company. We do financial and risk. So on the financial side, we do financial time series, real-time quotes, everything from the single millisecond latency, we don't do the HFT stuff, all the way to the end-of-day pricing reference at universities. From a data coverage perspective, we have over 80 billion instruments. This is going to be relevant in the latter part of the speech. We do everything from news, market data, pricing, reference data, company, risk and reg data. We do it all. We run the gamut. Some of our exclusive content. Some of the stuff I'm going to show you here today. We do data stream, which is economic data, time series data, fundamentals, the whole bit. If there's something that you need for that universe in the way of economic factor model and whatnot, we probably have it. TradeWeb, Starline, if any of those things resonate, it'd be great to talk later. Otherwise, so be it. Just generally, the company as a whole, one thing that's exciting to me is kind of the way that we're attacking cloud. We're going a very cloud agnostic strategy. We want to be where our customers are, where you are. So make it very easy to model and to do the pre-trade and post-trade and trade research that you need to. Which brings me back to the point. Markowitz, what are we talking about? What are we doing? So Markowitz portfolio optimization is basically a Monte Carlo simulation trying to estimate as many different weights for a portfolio of random assets. You can make it anywhere from 2 assets to infinite numbers of assets to determine the optimal weighting for a portfolio. And who cares? For people, it means money. Key terms, and probably needs no introduction to the folks in the audience. We'll be discussing Scala, Mahout, Spark, Zeppelin, decomposed distributed matrices, distributed parallel processing. For those in the audience that perhaps want to look it over the head, Scala is a programming language that we use to access Apache Spark. Mahout is an interpreted language that sits on top of Scala. It allows us to do fancy things like linear algebra, do a lot of economic time series problems and economic problems in general. Apache Spark, it's the engine of big data. A little bit more on that later. Apache Zeppelin, it's an IDE, a user interface that was created to be able to easily access Scala and Mahout. And even Python in the same interpreter if you'd like. And then decompose distributed matrices. This is kind of the power of just using this framework, of being able to use Apache Spark and use Mahout. Then you have the ability to take large matrices, break them apart, send them off into different cores and different computers, and then at the end, be able to collect all that data information back, and then get the same problem back. I'll have a funny joke about that in a little bit. All right, so what is Apache Spark? So I went off looking for a good explanation for you folks, and I came upon an explain like I'm 5 post on Reddit. Now I love Reddit, so bear with me. Explain like I'm 5. And I would never demean somebody that's looking to learn something. It's hard. Every time you take a learning journey, really you are taking a journey of where for weeks, months, perhaps years, you're going to feel like an idiot. Regardless, this is what I found with that in mind. What is Apache Spark? Where can I learn big data engineering? Is there any helpful online tutorial? Any resource where a complete beginner without any experience can learn this technology? It's going to be a lot of effort, to say the least. All right, so what is Apache Spark? Now, after doing some actual research and going to Apache's website, these are a few things popped in. So, as some background, Yahoo did a fantastic project that they ended up gifting back to Apache Software Foundation, wherein they created Hadoop. And Hadoop has been the engine of big data pretty much ever since. Apache Spark is something that is kind of like the next iteration. There's a lot of benefits. They still use the map and reduce of Apache Hadoop. However, they do a lot of things in memory, so they can do things a lot faster, which big data, speed equals time equals money. So as you can see, you can run workloads 100 times faster. There's generality, it provides a bunch of different data sources, and it runs everywhere. Funny joke. All right. And again, what is Mahout? Mahout is an interpreted language that sits on top of Scala, allows us to do the data analysis that is relevant for the purposes of Markowitz and any kind of linear algebra. And again, a very powerful point here is that you can break apart matrices, then recombine them after doing a ton of threads, either over a single machine or over a network of machines that easily collect them back so that you have relevant information to use. Right. Now, the finance piece. First, we're going to quickly touch on Markowitz. Then we'll talk on his theory of modern portfolio theory. Just quickly define what we get, say, is risk and returns here, as well as the Sharpe ratio. All right, so who was Harry Markowitz? This dapper young man over here. He was a 1990 Nobel winner for his theory of modern portfolio theory. In 1952, he created this model that would really fundamentally change the way that we think about modern finance today. It's modern portfolio theory. So a lot of the ideas that we have today about diversification of risk and multi-asset portfolios really stem from the research that he did and delivered back in 1952. He created the idea of an efficient set. So if we have the correct weightings for a portfolio of assets that, as we approximate and get closer to that efficient set, we have the most efficient portfolio, and thus are reducing the amount of risk and having the amount of returns we can for any composition of portfolios. Check, check. So what are the implications on risk management and finance as a whole? So this leads us to the capital asset pricing model, which is a net result of this research that really posits the correlation of individual assets against the broader market, which really opens up what later research would find about multi-factor models, about efficient risk portfolios, and really a lot about what modern quantitative finance is today. All right, so to quickly go over theory, so we can set up the rest of the problem, this is the 2-asset portfolio. This is probably, if you haven't seen this in finance, you'll probably see it in Finance 102. It's a fundamental basis for a lot of financial theory. The idea is that if you only have 2 assets, you have bonds and stocks, that of those 2 things, if they weren't correlated at all, this would be a straight line. And you can see that bonds generally have lower reward and lower risk. Stocks have higher reward, higher risk. However, a very unique thing happens when you start incrementally adding stocks to a bond portfolio. You lower the overall risk, and you heighten the overall return. Bada boom, now you know finance. However, as you start increasing over that composition, you you start seeing something too where you got a concave line over here. So it actually pays to continue to increase the amount of stocks that you have in that overall portfolio. Now, how do you determine that? That's where we're going to get to the Sharpe ratio again. And then generally to this point too, this also lends to the capital allocation line. This is the efficient frontier. This is the capital allocation line. We find the tangency, which we're going to do with the Sharpe ratio. And it also says that you can find returns beyond the efficient frontier by mixing in what over here the y-intercept is going to be the risk-free rate. If you increase values for the y-intercept with risk-free assets, you can actually get further beyond that efficient frontier. Okay, so a little bit about the capital markets. Why is this an issue? So you can create a portfolio with 2 assets. Simple. However, on Infinity, we have over 180,000 globally listed companies. That's a universe of 180,000 companies, which starts becoming very perilous to model. However, that's not even the end. We have over 27 million active RICs, which are identifier codes that we have in our system. So there's up to 27 million assets that you can model within our universe. However, that's not even the end, because Markowitz's original theory says the efficient portfolio considers everything in the available investable asset universe. So that means walking down the street to your local Goss & Grocer or McDonald's franchise and saying, hey, I want a piece of your franchise because I need to make my portfolio a little bit more optimal. That's not very efficient nor really possible. And then also even the drug dealer on the corner of the street slinging dime bags. Theoretically, you would need a piece of his business in order to get the most optimal portfolio. Why do we do that? For legal reasons, I'm going to defer that question. And then to that end too, the research I'm going to show you does daily returns. You can get as crazy with this as you want. You can go down to hourly, minute, tick bars, which are individual trades, and the data becomes really big, really quickly. All right, so this is the Markowitz bullet on the S&P 500. A few things that you'll see, there's a lot of available portfolios that we model. Now, with 500 companies and 3 years worth of daily data, this is what I was able to come up with. And in a lot of different iterations, I crushed it. All right, so what are the steps to get the Markowitz optimal portfolio? 1, load the data. 2, iterate to create the weight. I thought that was a nice way to say that. 3, calculate returns. 4, calculate risk. 5, looking sharp. All right, step 1, load the data. We didn't do this in the hoop iteration, but in Python, this could be very easily run on a nightly basis if you wanted to. This is just an API call into our data stream web service API. As you can see, very simple. There's already a Python wrapper around it. Call it in, pass your credentials, and then define your tickers, the fields, and the date frames that you want. That's in 3 years. And then we have a ticker that captures all the S&P 500 RICs, and when your hands are done, right? We also took the log returns of those prices, and then just dropped the first value because that's about it. As you can see on the bottom, this could be the output. It's going to be mostly a data frame, pretty easy to read. All right, iterate to create the weight. All right, so basically what this step in the process is telling us. All right, go ahead and iterate through a matrix that we've initialized with zeros. Go ahead, for every row that's available, we're going to define about 10,000 portfolios. You can make that as limitless as you want. You're going to get better returns at the end if you do, and you're just generating random numbers. That's it. That's the Monte Carlo simulation portion of this talk. Easy. And what I'm showing you here is the Python iteration of this, and this is how we did it in the Hoot. We did it with a few less portfolios. Full disclosure, I kept getting out of memory errors, but that must be my new ways. And these are, so just going through it very basically, you can see that the code is going to be fairly similar. Basically, down here, this is where we're generating a bunch of random numbers inside of this in-core weights object. And then down here, again, we're just normalizing this, taking the weight, dividing by the sum of the weights. After a lot of trial and error, I realized that I really need to blow out these weight numbers. Otherwise, everything was very tightly packed. I did that in Python iteration, very easy to do it in the iteration. Just to get step 3, calculate the returns. All right, so top row, we got the math. As you can see, pretty simple. Just take the weights, take the expected returns, and since it's daily data, you just multiply it times 252, number of trading days in the year. And then you see the Python iteration, the Mahout iteration, and the output. A few things to note, which is kind of cool about Mahout in this instance. It leverages a lot more natural mathematical notation and expression. So as you see here, this indicates that we're doing matrix math, and simple. You're just doing the weights matrix times the returns matrix, multiplying it times 252 to annualize it, and then you're collecting it after we've distributed it in the earlier step. You're going to get a vector output from returns. Step 4, calculate the risk. So this is the math. You're going to multiply the variance times the weights, and then multiply it again times the transposition of the weights. In Python, a pretty simple implementation if you've handled NumPy before. However, it doesn't look too natural. As you can see, we're doing matrix dot matrix multiplication using a method instead of the more natural use case that we could use, which is very similar to R, where it's just using the multiplication symbol for matrix algebra. A small note, so our pandas, they've had a lot of contributors and a lot of time to get it right, and a lot of different statisticians that have been on the platform for probably all longer. My understanding is only about 4 contributors on Mahout. Not their fault, probably our fault. So they don't have as many methods, but easy to solve. We did basically like an iteration over the matrix itself to try to get the diagonal, which ends up being the variance in this case. And this is the output, the vector output at the bottom. All right, looking sharp. Calculating the Sharpe ratio. What is the Sharpe ratio? Another Nobel laureate created this concept of the Sharpe ratio. It's a method to be able to tell to measure risk in financial markets. Really, you're just taking returns. You divide it by the variance in this case. The implementation in Python is pretty simple. And this is the whole key of this. You have to maximize that number in order to determine the optimal portfolio. The implementation comes out pretty easy. In Python, just using NumPy to call the position of that max on the Sharpe vector. And then this is how we do it in Mahout. The only difference that I kind of make here is that we had to do some weird tuple unpacking. Scala does it in this weird way where you underscore over 1, underscore over 2. That was my only right to pick. And then you're just getting one output, one single variable output. Again, this is how we got to it. So kind of a pretty cool implementation. And this all lends back with, now we were able to kind of have it with Python with a lot more efficient coding, writing a lot more things to disk to try to get an image like this and get the numbers back for what the weighting of the optimal portfolio using all the S&P 500 assets would look like. However, let's, again, liken it back to, what if we use 108,000 assets? Like, how could we push this star up here? Could we achieve 40% returns with an optimally global portfolio? Can we lessen our risk relative to the S&P 500 by just using this probabilistic data? Theoretically, yeah, absolutely. Which I guess puts the big asterisk on Markowitz. It's a very probabilistic model. There's not a lot of fundamental attribution for what's going on. One of the criticisms, actually. So, for instance, they treat everything as being a representation of past performance. There's no waiting for expected returns by how many tweets your CEO puts out, or how much systemic risk is introduced by the President of the United States sending out tweets. However, it's a very good model for thinking and creating and really taking the next step on your fundamental analysis of portfolio composition. My takeaways. All right, so you can't really see this, but it's a really funny meme that I saw on Reddit today. It's a guy using a big sword to cut his breakfast omelet, and then superimposed, the guy cutting it says me, the sword is Python, and the omelet is 12 times 4. It's a very good metaphor for use the best tool available for you. So while we like to say that you should use the best tool possibly available, there's a lot of limitations to that. So starting up with Hadoop takes a lot of time. There's time to learn the language, time to learn Apache Spark. There's just a lot of variables, and time is precious. And you probably want to go and outside and have a drink with your friends today on a Sunday day instead of sit inside and learn another programming language when you don't necessarily have to. However, if you're not necessarily dealing with megabytes of data and you're talking about something approaching gigabytes and perhaps terabytes and God forbid petabytes of data, perhaps you need a better tool. You need to be able to efficiently break this apart, send it over a farm of servers, and then be able to efficiently collect and really confidently collect, so you're not mangling the data on collection, so that you have some meaningful analysis to make from large sets of data. Now this is taking node like sampling methods into place. It's really taking Markowitz's original positing at its word and saying, let's just take every asset because we have the computing capability to do so. So this is another quote that really became relevant to me as I was going through this evolution. Scared to death, scared to look, because ain't no such thing as halfway across. So Apache works fantastic on Linux infrastructure. As I said earlier, I'm not a Linux guy, I'm a Windows guy. I begrudgingly left Excel to start using R, and my company is always going to be Windows. So I've really had no impetus to actually move over to Linux. So I started off a virtual machine, and I was a halfway crook. All the Apache software wasn't playing friendly with me on a virtual machine. Through a lot of iterations, a lot of hours, I got pretty close, but not all the way there. So part of my takeaways is, hey, if you're going to do this and you really need to use Hadoop in a deployed infrastructure environment, you gotta go 2 feet in. There's no halfway in with Apache Zeppelin and Apache root. So thank you for your time. I know we have a cocktail hour afterwards. I look forward to talking to you. Thanks. Questions?
Did you experiment with any other loss functions that are efficient variants, such as kurtosis?
So in finance, we don't do a lot of trade math. Well, that's the first answer.
Well, that's where you work. I'm a professor of finance right now, and I ran a commodity trading fund for a while.
So in practitioner, you model all this. And, in my application, it was more so the tech that I wanted to display than the actual. I wouldn't run this into production anytime soon. Yeah. Nor would I trade on this. Anybody that's out there, do not trade on what I just said. I feel like that's a FINRA requirement.
I see. Yeah, live stream say that.
But the answer is no. I obviously like to be like step one. You model it all, share on their assumptions. Yeah, cool.
I was wondering.
Oh, we had a closer? I don't even remember that being on the schedule.
It's not, which I learned today.
Then why do you sell this out?
But I said,